Today we're going to do something slightly different. I want to continue the discussion that Rob did talking about generated code. And when he was going over that presentation, we touched on frameworks and how when you generate code, typically you get locked into a general framework that is provided by whatever the tool is that you're subscribed to that generates some software. Now, this is a sample of one of the projects I'm currently working with my company, and this has been generated using my generated tool. But my tool itself is actually building you a test framework using the best practices of what's in the industry right now with Selenium, with Maven, with TestNG, and a lot of the other best practices and kind of software practices that I've run into while working with this software and these open source frameworks over the last 5 years. So here we have a Maven project, which at the high level, we have our folders, source main Java, our resource folder for our main resources. And then we also have our test folder for our Java test. This is actually where we're actually going to write our Java classes that are going to contain the scripts, the page flows, the test cases, the test suites of our test. And then the test resources is going to contain things like our properties files, our TestNG files, and our data files and things like that. Now, in my framework, I also include a couple additional things. So I also include an HTML folder, which a lot of people may not like this, but when I actually generate my software, my software tool actually takes a sitemap. So it will take a website XML file, or it will just take a list of, or you can actually store all the source information for each of your web pages from your sitemap into a folder. Then when the tool runs, it will generate this framework here. It will also copy down, it'll either copy over or download the actual source of the pages at the time the code was generated. I do this for two reasons. One, at the time the code gets generated, or at the time you're actually building your test suite for your application, it's kind of good to have a snapshot of what the website looked like at the beginning of the project. The other thing is, if you ever go back and you have to re-download a page because a page has drastically changed, you can then keep track of these versions within your version control software, be it Git or Subversion. So this is what I do here. However, these can get fairly big, so you could compress these, but as long as you keep them in your project, you can kind of keep a secondary version control. Some might argue that this is redundant because you already have the projects that build the software. Unless you're dealing with a static site, if most web applications are actually dynamically generated. So the pages are constantly being updated and generated on the fly. So you actually don't have the static HTML code for most of these projects. So when you're actually testing it, you're building your test scripts, it's kind of actually good to take a snapshot of the source code at the time that you're building the test. That way you can always refer back to this and pull up, like here, the agency select. We see we have our HTML code. You can skim through, see that you have some JavaScript. You see you have some inputs. You can also eyeball this and see that, oh, hey, here they're using button type selection form. They're using the name ID here, but ironically enough, they're actually assigning the ID for the BU type selection form as an actual form ID here. So this is a little confusing because when you actually want to interact with this select here, you have to actually go in and actually get the ID by name, not the ID. Because if you're actually trying to test this or automate your software test to actually communicate with this dropdown here, if you use ID, you're going to get the form, which means you won't be able to actually work the select field. So having this, you can actually kind of eyeball, walk through, and then you could say, oh, well, this right here is a potential problem because also here you have BU type selection form as the name here. So really, you should not have two name fields with the same name. This is bad. So you kind of want to watch out for things like that. And then what you can do is you can open up a defect, send it back to the developer and say, hey, you actually are generating code, great, but your page actually has redundant IDs, which means if we have JavaScript and you're trying to interact with this page with JavaScript, it could get confused. Just like our test will get confused if we try to use Selenium to look this up by name or by ID. And then some other things you can do is you can come in here, and by keeping snapshots like this, it's actually interesting to see what gets generated on the page. So here are the values for the current user that we use for this particular application. I've had to update this one a couple different times because over the 5 years I've been working on this project, we've gone from 3 or 4 agencies up to about 20 agencies. So as you can see, I'm about halfway through the project, but I'm going to have to update this again once I do the remainder of the agencies. And the reason I do that too is because in the framework, having all that here, if at some point we have a defect later or the automation fails, you can look here and say, well, here on such and such date when we pulled this down, all this data was in the source code. Here is my physical proof that it was there. So it's kind of redundancy check and a backup for you. So if we actually go into our framework, so let's just start on the test side of things. So in our resource folder, you want to have things like your data sets, your property files, and if you're using TestNG like I am, you also will have your test suites. If you're using Cucumber, this could be your Cucumber suites, whatever your test scripts are to actually kick off your tests. So TestNG uses XML, which I really like because I can actually pull up the TestNG XML here, look at the source, and it's really clean. I have a listener here that runs in the background when I run my test, and the listener actually connects me to things like Jira. It connects me to things like our database. So the listener actually opens up the communication for our test application for us to actually communicate with other third-party devices. Within here, we can then list our test. So here, I want to run a simple page test, and it's going to open up the browser. It's going to try to go to some dummy URL because this is just a sample. It's going to open up an XML file, a workbook, and that's stored in the dataset spreadsheet. And then here, as I do have Jira integration, I can actually assign it a Jira number. So this will actually connect it to Jira. So if the test runs, it will open up Jira, see if the ticket is open. If the ticket is open, and it is in a runnable state, this ticket or this test will run. If the ticket is closed, resolved, or paused in a blocked state, our test will be skipped for our regression, our test run. So we actually don't have to come into our code and constantly update our projects and our test suite as to what needs to run. All that can be managed in this case through Jira. Now we could also do it from our test cases using additional parameters that we can pass in for group IDs. So we can group our tests together. Discussed that when I talked about the TestNG. So other things we can do, we could actually come in here and this one doesn't have it. Same one. Another thing you could do, and here we are. So I've actually broken out test suites by agency. So each agency in this particular application has a different page flow and has a different functionality with the way the application works based on the agency. So I've actually broken it down, extrapolated it one more level for agency. Then I have Alabama, and Alabama has all these different certificate test cases that we can run. Now, I have the test suite here for Alabama. And here we go. This is the example I'm looking for. So what you can actually do with TestNG, which is really cool, is you can actually create a test suite of suites. So I'm actually pointing this test suite here to the adoption test, the birth certificate test, the death test. If I go under those, then I see the actual individual test cases for those test suites. So I can actually combine test suites together to form my overall regression test for this application. Some other things I've added, and you really should have these in your framework, especially if you're doing any type of Selenium testing, is have a properties file. So I have properties files for my Jira integration, for my log4j. I even have some logging properties in here because I'm looking to transition away from log4j and use the built-in logger now that's within Java. So to do that, I'm kind of transitioning this over through phases from log4j to logging. Then I also have one for WebDriver. So within Selenium, if you go back to our Selenium videos, we talked about using the Selenium IDE to actually record our tests, but then you can export your tests as JUnit or TestNG tests, Java tests. Now, when you get into Java, it's nice to actually have some WebDriver properties. And what you can do with this is you can actually configure how many times you want a test to be retried if it fails. So here I created a little property for retry. Now it's set to 0 because right now I'm still building out the rest of the test for this application. So I really don't want it to automatically rerun the test yet. But once this is live, I will probably turn this on to 2 and have the system automatically retry a failed test once or twice. Reason I do that, now some websites will tell you that you really don't want to do this. If a test fails, you want to fail it, you want to send it up, and you want to basically have a tester manually walk through that particular scenario and ensure that we don't have a defect. That's all fine and dandy, but in a lot of QA environments, you have situations where your environment may be a little bit unstable because there's constant deploys going on, or you may not have a lot of resources dependent in your QA environment like you do in production. So after a deploy happens, there might be a lot of caching issues, or you might have some performance issues as everyone gets back on the system. So what I like to do here, though, is I like to allow at least 2 retries. What this enables us to do is for sites, especially like this one, are very heavily dependent upon AJAX. There is a lot of asynchronous calls going on back and forth in the system. Not only that, this particular system even has additional APIs to other third parties that we don't even control within the company. So we have proxies in that we can use for testing, but there are times those proxies are down or there's communication issues back and forth. So by allowing the retry, I'm allowing the system to kind of self-heal itself. It will go through, run the test again. If the back end is stable again or the communication is back up, the test will pass. So I give it 2 options to do that. If it fails after that, then I know there's something really wrong with that particular test, and I need to go back in and look at that. Some other things I've included are kind of coincide with this. So as the tests are running, as we're doing our lookups of our pages, we do things like page load retries. So web pages and browsers specifically are a little bad about this. They don't really send a command back to the browser saying, hey, I'm done loading. Especially in some cases where if a page has an ad constantly being refreshed, JavaScript is constantly sending AJAX calls, so the page is never officially loaded. It's constantly updating, constantly loading. So you need to give your tests time, or not really your tests, you need to give the web driver or whatever tool you're using to communicate with your browsers time to let the browser page load. And in that case, you could still run into speed issues again in performance. So what I've done here is I've actually broken it down into 4 categories. I have page load retries and page load delay. Now, the page load retries only affects when I'm testing if a page loads, where I'm looking for the elements on the page. And then the page load delay is if for any reason I get like a stale state exception or I get an element not found exception, I will pause for 30 seconds and then I will retry, check that element again. If for some reason the page loads and then I try to interact with an element on the page and I get an exception, that's where the page element retries comes in. One of the biggest annoying features, well, not annoying features, but one of the biggest annoyances when trying to build test cases and any type of test suite for web-based applications is you have to deal with the browsers. And the browsers are constantly updating, constantly changing the way they do things, and also constantly changing the way they want you to load your pages. For example, to be a higher ranked on a Google search, you have to load all your JavaScript and all your CSS, and that at the end of the page load. That way, all your text loads quickly, the page, your site is up, and then you apply all the style. Well, that's all fine and dandy, but if you're trying to test something, if, for example, you try to interact with that input field before the style or the JavaScript has actually executed, you will get things like stale state exception or element not in a state that's clickable, or even possibly, oh, the DOM object you're trying to communicate with has moved. So if you're actually trying to do like an XPath lookup, you might actually get an element that's not what you want. So those particular errors you can kind of self-heal from, and I've got code built into the framework that will do that. To handle that, that's what these element retries are for. Under properties, also, I have local and remote because I'm now starting to expand out my framework to handle containers. So we can actually start testing our test suites through Docker, through a Selenium grid. So to do that, I've actually implemented two different sets of properties files, one for if you're testing locally, and then one if you're testing a browser through a remote container or a remote machine. What's neat about this is I have a list of every possible combination you can interact with Chrome. These are all the command line options you can manipulate, and Chrome has a lot. Unfortunately, Chrome is also notorious for dropping things per browser and adding things constantly with each update. So this file is fairly long, but at the top, I put most of the most commonly used properties. Things like allow insecure local host. You can assign the bit if you want to use a 64-bit WebDriver to test your browser or a 32-bit WebDriver to test your browser. You can disable things like cache, which as testers, we all know that cache is the bane of our existence. We could test a page one moment, and then a developer deploys something. If we did not clear our cache, potentially might not be testing the new changes. And then you have to go in and clear cache. The nice part is most of the new browsers today support things like private mode, where you can actually open up the web browser with like Control-Shift-N, and it opens it up with no cookies turned on, no caching. So essentially everything is disabled for testing, which makes it a lot easier. We're essentially doing that here within our automated testing. We have to essentially tell the browser that at the startup. We have things like disable cache, disable logging, no sandbox. This is actually notorious in Chrome. Purge caching. These are nice if you're running interactively. You can actually start your browser full screen or start maximize. These are essentially the same thing, but just depending upon if you actually want the full screen to be as if you hit F11, or if you still want to see the Windows bar or your Mac menu bar, you want to run it as start maximize. If you're running it headless, which a lot of the new browsers like Chrome, Firefox, and now since Microsoft Edge is a Chromium build, you can now even run Edge headless. This is really great because you don't have to sit there and actually watch the test run and see the browser pop up continuously. When you're running multi-threaded testing, you don't want that. You want to basically utilize as much system resources as possible. So running headless removes that GUI and it really speeds up your processing speeds. The downside is if you're running headless, most browsers will default to 800 by 600, which for most modern day applications isn't really going to display your page correctly. And that could cause some testing issues. So what you really need to do is you need to set your window size here to actually be the minimum supported size for your site. Now, it's kind of interesting. As I've been testing at this company for 5 years. I found that I am up to 6 different applications now, and 3 of the applications, they had no idea what their minimum supported Windows browser resolution was. And in a particular case of this particular app, it actually has a minimum supported size of 1024 by 800. I'm actually using an ultra wide monitor here, and I've actually found that at the high resolution of this monitor causes issues with our application. And I've even reported that as a defect, but they're kind of letting that script by right now because at some point they're going to redo this entire application and hopefully fix a lot of the issues that we have. But again, by doing this, I can go make a configuration change, just push this out to my test servers, and boom, we're up and running. I don't actually have to touch code or actually touch the individual test cases themselves. Any questions at this point?
None here.
Next, we have our data sets. And within our data sets, so one of the biggest problems I have with this particular company is I told them this 5 years ago that we really do not want to use spreadsheets for our test data. 5 years later, we're still using spreadsheets. The framework is actually built in such a way that you can actually pull test data from any format. You can pull it from JSON, spreadsheets, CS file or CSV files. You can actually pull it from databases. You can pull it from APIs. So this framework actually supports any type of data input possible. The problem I have with the current company is I'm only allowed to support spreadsheets, which can get extremely ugly. But I've broken the spreadsheets down again by agency. So we actually have our test data for each of our individual certificate tests. So here we have a adoption certificate test. I have an adoption spreadsheet file. So if I open up this guy, did not open. Right click, open with. Enjoy. Why are you bombing? Well, that tries to come back. Let me switch to a different window here. Here we go. All right, so make this guy bigger. All right, so what I've done with our spreadsheets is I've actually created a worksheet for each individual page in our sitemap. The reason I did this and I didn't combine all of these on one individual page is that some pages reuse the same ID again and again. And in the case of some websites, you have menus or navigation bars across all pages. So they will share the same IDs if you're pulling the source and generating IDs. So what I've done here is if we select login, we can actually pick our, so we have our sequence field here. This is the ID we use for our tests. Now in this case, I'm using Jira, but it could be anything. It could just be a number. It could be an alphanumeric code. But this is what you tie into your test, into the actual individual test cases that you define in your test suite. And then we actually go and we get the individual IDs or name fields that are on the page that we want to interact with and put data in. So this is doing a version of, or a hybrid version of testing framework, where I'm letting the data, in a sense, drive our test case, drives the page flow. So depending on the certain types of data we have, when we go look at the actual test cases, you'll see that we're actually pushing the data through, and it actually can change the flow, the path of the tests. This is a great way of doing it where you actually don't have to script multiple test cases. You can actually write one test case, let the data drive it, but you need to make sure that in your test case, you actually define some type of output to let the user know what path you're going down. And we have things like test terms and conditions, which here we're just using, it's a Boolean checkbox. Agency select the different agencies. So in this particular case, Alabama, nothing for search order. Order detail contains most of the data. This is one of the things they need to fix about this site is this particular page is very memory heavy, very browser heavy. It actually, once you load this page, there's so much JavaScript, so much visual inputs being loaded, and so much going on behind the scenes with Ajax. So as you can see here, we have a lot of test data involved with that. Okay, let's close that one and switch back over to Eclipse. All right, so that is our test data. But now, if we actually go look at our test framework, so again, we're using the com.vitalcheck. I essentially generate within my tool a couple different files for you. I build a base test, which this here contains all your framework information for your test. It contains your WebDriver registry. It actually points you to your data object factory, which the data objects actually match up to those spreadsheets. We have a page flow factory. So what doesn't get generated is we actually generate a page flow template for you to use, but then you have to actually physically go through and actually build the individual page flows for each page. We can't necessarily do that for you because we don't know the use cases for every page. But I make it very simple here where all you have to do for page flows is you go to a page flow package and update your page flow classes. We define what we want to do here. We register the pages. So we're actually registering the individual page objects for the sitemap. Now, what's neat about these is I'm only loading them as we hit the pages. I registered the objects, but they're all null till you actually physically hit the page. This was one thing about the Selenium framework I did not like is when you're doing page object factory or the page object model, by default, they tell you to go ahead and register all your web elements in your page object. The problem with that is if you have large sites like this one, you could potentially have 200-300 web elements that you're trying to register on the page load. And like this one, there's a lot of hidden features that are not displayed initially. And there's a lot of features that you may never touch on the page. So why should you eat up a lot of your memory for something that you're never going to use? So I took a different approach within this framework, and we'll get to that in a minute. Other things that you want to do here, we have the TestNG, which is like JUnit. We can do things like after the test. In this case, we're going to tear down our WebDriver and close the browser. We also have things where we're going to set up the custom object factory. And as you can see here, I've created some custom exceptions for different things. I've actually tried to wrap everywhere in the application. So if there's any type of null, you actually know what is going on, what has happened, and what you need to do to fix it. So in this case, if we actually try to set or look up our custom data object factory, in our case, we're using Jira. Now, the Jira issue could actually just be issue. And that revision might come later. But for now, since I really try to support Jira and a lot of people do use Jira, I've left it in there for now. But if you come in, if you try to pass in your workbook and you try to go look up your test data, if you don't have an issue ID, it's going to throw you a null pointer exception saying, hey, the test parameter Jira string cannot be null. And then if you try to, again, set up a data object and you forget to pass in your workbook, you, again, get an exception right off the bat, hey, the test parameter workbook string cannot be null. I find this approach to be very efficient throughout the application, throughout the framework, is always do your validation checks like this at the beginning of the method. If you do it quickly, you reduce the amount of load time, the amount of objects and parameters and methods and things that get loaded into memory, because the moment it fails, boom, kicked out, application closes. Then we go in and we actually register our object factory, and it actually assigns the workbook and that into the factory. And then as you actually load the data objects, it will pull them from the page. So we're actually loading all the data into memory in one big shot. Other things the framework does is I allow you to pass in the parameter from the test suite from the XML file, and that could be from the top suite level, or you could even customize it all the way down to the test case. As long as you have the parameter browser, you can then tell it that you want to do Chrome. What's cool about this is you can actually take the same test case and actually repeat it 5 times and apply it to Safari, Chrome, Firefox, Edge, Found.js, whichever browsers you want to do. So it's a very easy way for you to create one test suite with 5 test cases to test browser compatibility. You don't have to create new data sets, already have the data, but in this case, all you have to do is change a parameter. You don't have to change anything else. And the last one here is the URL. So this, again, is a parameter that gets passed in, built into the framework. And again, I do this at the configuration level because you can then set up your test suite to running QA from this instance. But I can just as easily change the URL and point the same QA test data to development or to production or to a UAT environment. So it's just all configuration. It's all customization. Something else out of the box, you get the Retry Analyzer. This is configurations you need by default from TestNG to apply a retry. Again, this is all managed through that properties file. And then I also throw in a generated test object. And what's neat about this is it comes with some basic information. It's a simple POJO that contains things like your error message, the Jira number or sequence number. If you have an order number, a pin number, it also gets your screenshot name. So when the test fails, you actually have some customization you can do, and you can turn it on or turn off if you want it to the test to actually capture the browser at the point of failure. So you can actually see if you have an error message on the screen, you can actually see what's going on. The screenshot path, the status, did it pass, fail, did it skip the test, the test name that the test contained, and the test suite. Now, having all this information in a POJO is really nice because now you can pass this back and forth through your listener, through your tests, through your test suites. And if you have to actually ever chain or group tests, which is really not necessarily an accepted behavior, but there are test cases where if you design your tests correctly, where you actually build things at a kind of a point of like a unit of tests. So like create a user. But what if you are creating an order and you have an application that in order to process the order from beginning to end, you have 4 user roles? Well, you could create one massive test case that logs in as one user, creates the order, logs out, logs in as the next user, updates the order, logs out. Another user logs in, confirms the order, logs out. Next person logs in, confirms the order and ships the order and confirms payment and then logs out. Well, yes, you can build that as one test case, but ideally the best practice is you should build an individual test case for the first user, an individual test case for the second user, an individual test case for the third user, and so on. The issue, though, is you need to actually pass a value from the first test to the supplement tests. And this is where best practice really frowns upon this. But in this particular case, I say best practice be damned. The best practice in this case really should be the first test runs, it generates the order ID or the unique ID to access that particular test data. And what you do is you push that value back up into the listener. And then when your next test runs, it can pull that data out of the listener into your next test. And to me, all we're doing there is we're kind of dynamically generating our test data on the fly. We're not necessarily pulling it from a database, or we're not pulling it from a spreadsheet, but we're pulling it from another test scenario. To me, it's the same as using an API to pull an order number to complete a test. So you can look at it both ways. I like doing it this way, and I think it's a better way of doing it. A couple other people that have run into similar scenarios kind of like this approach better. So I'm sticking this in my framework and kind of pushing this out as a best practice. Within listeners, you have things like your screenshot listener. When the test fails and you actually get to the end of the test suite, it will call this listener and it will then go out and generate the screenshots for each of your browsers. I'm sorry. What this actually does is when the test fails, it generates the screenshot. It updates the test object with the screenshot information. And then when the suite finishes, it will then go pull all those screenshots and then push it out into the reporting framework. We have a WebDriver listener. This by default contains your on start. This here is an example of how you can actually add and push variables into the test suite memory, into the listener. So this is actually how we push those order numbers back and forth between test suite or test cases. And then last, we have our page flows. So by default, this just generates your control factory and your data object factory for your page flow factory. What you actually do is you actually come out here, and this is everything that you can build upon. So I give you all of this to start with within your framework. And then all you have to do is you come into your library, you have custom-based test, and in here you can add any additional things you need at the time that the test starts up. You can register other classes, you can register objects, build things that you need for your tests that are common across all tests. You can also override anything that I've done in the base test. Everything I have built in this framework is fully customizable and owned by the user. The only thing you don't want to do is you don't want to actually go in and change anything in the generated piece, because as it implies, if you ever regenerate your code, it's going to wipe that package and rebuild it. So everything you want to do is in the custom section here. Custom Retry Analyzer. If you want to override any of the retry logic, you do that here. And then finally, we have the custom test object. So here's a good point here. I've actually had to create and override 3 different constants so that I can actually find these in memory. So I can actually push the JIRA issue, I can push the order number, and I can push the pin up into memory and pull it out for another test case if I need to. And then here I'm actually calling the parent constructor from the generated code, so I can actually have this data and I can pull the data from the original object. Again, you have your custom screenshot listener, which I'm not really customizing because the way I have built it, it should work for you 100% out of the box. But if you don't like the naming conventions, or you don't like the packages or the framework where I'm storing them, you can come in here and override all those values. Other things, we have the custom WebDriver listener. So this is kind of the crux of my test framework. So when you actually kick off your test, this guy is running in memory. Back up here. There we go. This guy gets kicked off at the start of the test run. So he is running in memory, he's running in the background. So he's keeping track of things like when a test fails, when a test passes. It also handles things like when the test finishes. We can also do things like handle the transformer. So raw types here, within the transformer, if the test failed and we have the retry analyzer turned on, or we have our retry set to something greater than 0, it will come in here and it will register the retry. And once the test suite is done, if it failed, it will kick it off and try again. When the test is successful here, I'm adding the success, the test object, to my pass array. I basically built a hash map here. Let's see, on test start, if I actually handle the results. So there's two different test cases here. We have on test success, on test start, if we want to do anything at the start of the test. If the test gets skipped, I store some additional information here, skipped. If it fails, this is where a lot of things happen. So here, this is where I'm creating the screenshot or pulling the screenshot out. I'm getting the path, I'm putting it into the actual test object. And then when the suite's finished, I use on finish. And in here, I actually loop through the test object. I figure out, okay, did it pass? Did it fail? Did it skip? And then I go through and get the counts for everything. And then I generate a console report here that actually tells me, okay, what happened for each individual test suite, what passed, what failed, what was skipped. Then I write out the failure messages that were for all the test suites. And if you comment or uncomment the section here, in the latest version, this guy is actually configured by a parameter, a properties parameter. But what you can do is you can turn on the debugger to actually write out all the data that is in your test object. So you can actually see everything that passed, all the order IDs, all the pins, which you might need if something failed to send it over to a manual tester to actually have them go look at the system or look in the logs to see why something failed. Some other things I'm doing here, I'm keeping track of when the test suite started, on the individual. So if I have nested test suites, I keep track of when every single test suite kicks off, how long each one takes to run. Before invocation here, I get the property values, I get the JIRA. Here I'm pushing the JIRA key into memory. And at the end of the test suite, if I had another test scenario that ran after this, I could actually push up the order number or the pin and then pull that out in the next test as well. Other things that I've built into the framework. So we have page flow. So this is an interesting concept because I really subscribe to this model where you should actually, when you're building web-based testing, you really should build your page flows and build the page logic and the individual test cases for how the page interacts in the actual page flow, not in the actual test, but in its own particular place. Now, that's not to say that you still shouldn't actually build your page object, which we'll get to that in a minute, but the page flow is separate from the page object. Page flow actually defines how you navigate or how you interact with each individual page. And so what I do here, if we come into, let's look at the login page. So I've defined a couple different cases. And if you notice, each of these that are public, that's not the constructor, will actually return us back to the same class. So I can do things like validate page information, but then I can immediately chain that with populate login, continue to next page. What I've toyed around with this is every time you actually load a page or you can basically communicate and you get the page flow for a particular page, it is by default going to verify that that page, the page objects that are needed by default are loaded. So the moment I actually get the page flow, it's going to tell me, is this page loaded? Is it ready to use? If it's not, it's going to fail immediately and it's going to stop the test. We don't even have to get into the actual interaction of the test to know that, oh, we actually failed way back a couple steps previously. So this is just an approach I put in as best practice within the framework, and it seems to work great to handle if a particular page is broken, it stops your test run in its tracks. So here I use the factory, I call the individual pages. So I got login, so I can actually hit dot here. So I've got agency select, payment, shipping labels. So all the different pages within the framework or within the application. So here I'm calling the services. Services are within the controller, which allow me to actually use any of the action methods within the application. So I can do things like populate, click log information. What else do I have here? I think I have, then I have some of the validators. So I have is page displayed, is page links valid, is page text displayed, is pop-up displayed, and populate. Now, you could use the validators here, but really, if you want to use the validators, you should use the assertion method here. Simply because assertions are another part of the framework where you actually custom define the messages that get outputted if a particular page doesn't load, if the links are invalid. So you actually customize everything within the application, within the framework, and it keeps it clean. So you always know what's really going on if the test fails. So that's the page flows. Then we have our test cases, which here I have some samples. So we have create or check edge browser compatibility. So here I have to actually hard code the web edge driver. I tell it where to go to get it, and then I load up some properties, and I just do a quick walkthrough to see if the page loads. The actual test that I'm using for this particular site is this. So it's fairly clean. You come in here before the before method gets initialized and run at the start of the test. So before before it actually calls our test method, it calls our setup method first. And what this does is it will take a workbook and it will take your sequence ID and it uses this to pull the test data in for this particular test. What's cool about this is you can actually copy and paste your spreadsheets, create additional spreadsheets for other mock data or environments if you're trying to test this test in a different way. You come in, you get your page flow, you pick your page, log in, and then you pick your method that you want to do. In this case, the first thing I do is populate, log in, continue to next page. What's cool here though is login. The moment you hit login, it's validated that the page is loaded. Then we populate and log into the next page. Then again, we get our page flow, we go to the terms and conditions page, and we populate, continue to the next page. Everything I've done in the framework is designed for best naming practices. So you don't have to really spend a whole lot of time writing complex documentation about what the test cases are doing. You should be able by default to just read the test case itself and you know what is going on. The only place where this can get a little tricky is if your data is actually changing the flow. But really, for this particular application, you don't see that. If there is some data that changes the flow, you'll actually see some if conditions in here, and you'll see some path information where it will go down different subsections or different branches of the tree to actually complete the test. And then the last thing I do here is I'm actually getting the order number. I'm actually getting the parameters. This line right here actually gets all of the parameters that are loaded in memory in the listener and in the test suite or TestNG memory. It pulls all the parameters out. Here, I am then putting my order number into that queue, into that parameter suite, and then I push all the parameters back into memory. So essentially, I pull them down, add it to it, and then I push it back up, resetting the parameters in memory. So this is how you kind of pass the value back and forth. That's the test cases, and that's about where I would like to stop today, except I'm going to quickly show you one additional feature here. So one additional thing that I've added to my framework that a lot of people I see on the news groups and on the forums about people having problems running WebDriver, about people running Selenium. And a lot of people put like little hack solutions out there on, oh, well, you could try this and this may work, or oh, this works in this situation, but not in this situation. So what I've actually done is I've actually created this little batch file here. And let me open it with the text editor. And what this guy does is at the end of your test, if you are constantly running in development, you're constantly having to stop and break your application or your test suite because, oops, I forgot to add some data, or oops, I didn't do this. And you run into that a lot. The problem is if you constantly are hitting the stop button, which is the hard stop in Eclipse, you're leaving things open in memory. And WebDriver is notorious for getting lost if it doesn't complete correctly, or if the close methods are not implemented uh, in the right way. So what you potentially can do is you can have these orphaned objects out there in memory, and at some point your system is going to become unstable and it is going to crash. So what I've added here is I've added a batch file, and there is a shell script too for Mac that will actually go out and it will find the Chrome executable. It will find the Chrome driver. It will find the Firefox. It will find the Gecko driver, so on. And what it does is when you are done with the test, it kicks this guy off and it will guarantees that everything is closed, everything is done, everything is cleaned up correctly. But if you're killing the test ahead of time, all you have to do is come in here and click this file, and boom, you've got a clean environment. You don't have to reboot, you don't have to shut down. Everything's good and ready to go. Also, I have this setup batch file here. Open that one up too. And this guy includes a Maven install script that allows us to actually include our custom Jira integration file for this company. So I'm actually using their custom Jira, which has some additional configurations for their setup, their Jira environment. But I have a default package one that I include by default within the standard. Now, if you don't use Jira, you don't need to include this. All you have to do is come into your POM file and take out this repository here, and everything's hunky-dory. I do a lot of dependencies. If you see here, these are all open source and Apache licensed third-party dependencies we use. I use Java Faker to generate mock test data for our test. I use this class or this jar file here, WebDriver Manager, to actually dynamically pull down the latest WebDriver or a specific version of a WebDriver for a browser that I need to test. So I don't have to go out anymore and make sure I'm always downloading the correct WebDriver before I execute the tests. We use TestNG, we use Selenium, so we need all the Selenium dependency packages. I also still use Phantom.js. I know it's been sunsetted now that Edge is now supporting, or Edge is now basically a mask on top of Chromium. Phantom.js will probably just be here for legacy purposes because under Firefox, Chrome, and Edge, you can now run all those browsers headless in Linux, in on Mac, on Windows, so pretty much on any operating system, you can actually test these browsers. I use Poi from Apache that's our spreadsheet interface that allows us to actually read the spreadsheets and manipulate the spreadsheets. I use ReportNG to generate some additional reporting beyond just the TestNG. We use Goose or Juice for some of our JSON, JSON interactions. Again, Velocity, Log4j Core for logging, JSON for JSON for loading of JSON files. Loosen, Fontbox, PDF Box. I use these for scanning, reading, and manipulating PDF files to verify that the PDFs are loaded correctly and that they match what should be there. And the last one's just the Jira integration for using the Jira interface and communicating with Jira. So I think I will stop there because that's a pretty good coverage of just using the TestNG test side of the framework. There are some additional features that I'll cover next time. I'll get into the actual Java side of the framework where we actually will look at things like the assertions, the builders, the controllers, and so on. But as you can see here, though, even though this is generated code, it's all open source, it's all cleanly defined, and it's all completely customizable by the end user. So as long as they do not go in and customize any of the core classes, which they shouldn't have to because everything extends from the base, you can use the tool to regenerate your page or your test, and you will just out of the box have all the latest updates to your site, and you'll be able to hit the ground running and testing. The only thing you'll need to add to your additional test after a refresh could be things like, new IDs have been added to a page. I need to add some custom test data for that. Or, IDs have been removed from a page. I need to go look and see why they were removed. And if we had any test data for those IDs, why was it removed? Is this a defect? Do we need to change the test data, or do we need to point to something else? So just to recap, this is one particular framework approach that you can do to testing, to building out your applications, your frameworks for your testing. I mean, you can use generated tools, or as you can see here, you could actually just out of the box start building. But having a framework in mind as you're designing your test projects or you're designing your applications really helps you lay out your project in such a way that anyone can come in, take a look at what you have, and hit the ground running. If you don't get too complex with your naming, anyone should be able to walk into this either having some test knowledge, some Java knowledge, and they should know what to do. They should be able to figure it out. Especially if you have a little bit of documentation, but you don't need to sit there and document every single file. As you can see, the name almost tells you everything. Like check edit browser, page flow. Oh, okay, here's my page flows for my order detail page, my login page. Here are my listeners, okay? Custom screenshot listener. Tells you what it is. It's screenshots. Web driver listener. This is the listener as we walk through the applications. And again, your libraries. So that's it for today. Does anyone have any questions?
Yeah, I have a question on your source test data, like that Excel sheet you open. Are you the one who updates it because it looks so huge? And I know you talked about like you didn't want to use Excel. So, I mean, how would you deal with such a huge file or something like that?
Well, the file itself, in this particular example, the file itself really is not that big. If I can get the properties up. I mean, we're talking 215 megs or kilobytes. I mean, it's a very small file. And in this particular case, this file is manageable. We only have 3 data sets so far. But I have another application for Vitals that supports all 50 states, and each state can have multiple agencies within that state, and each agency can actually have additional different data sets which actually drive different page flows and different navigations through the site. And we actually have spreadsheets for every single product ID for every single agency. I actually have probably on an average right now of about 500 to 1,000 spreadsheets that I'm having to maintain for that application. Where really it just needs to be a database, and all I need to do is go in and pull a query, and I can update data for a particular field across either a test case, a test suite, or an agency.
Oh, okay. So you don't prefer Excel, isn't it? It will be much easier than you doing the
Right. It would be it'd just be a database. So there would be a properties file for the database connection, and then instead of your spreadsheets here, what you actually have here is you would have your essentially you would have your keys for or your query to pull the data for that particular data set.
Gotcha. Okay. Cool.
Thank you. We know your time is important, and if you would like to discuss any additional questions or comments you have, you can check us out on info@developerner.com. You can check us out on developerner.com/contact us. We're on Twitter @developerner, and we're also on facebook.com @developerner. Our goal is making every developer better, so please check us out, ask us questions, and check out some of our other videos.